So the magnitude of x is 7.4 meters per second. And then to figure out angle theta, you use tan, and you get 24.8 degrees. So therefore, the resultant velocity of the boat is 7.4 meters per second east, 24.8 degrees north. All right, so for question number 2, if the boat takes 11 seconds to cross, how wide is the river? How far north has it traveled? Well, there's a few different ways you can do this. One way is to look at the vector components. So we figured out what the resultant velocity is. The boat's going off in kind of that direction. We know the exact direction is 7.4 meters per second east, 24.8 degrees north. So every second, how far does the boat travel? 7.4 meters in this general direction, east, 24.8 degrees north. But at each second, how far towards the east does it travel? Just looking at its eastward movement. So even though it's getting a push from the river, each second it is moving 6.7 meters towards the east. How far north is it moving each second? 3.1. So it's moving 3.1 meters per second towards north. Now, it doesn't actually follow these green lines. It doesn't go exactly east and then exactly north. It goes along the red line, which is our resultant. But the red line is a result of adding these two vectors together. So it is a combination of its eastward movement and its northward movement. And if it suits us, we can look at those separately still. Even though it's going along this line here, it still goes east and it still goes north. It just does them both at the same time. Okay? So if we wanted to know how far east does it go in 11 seconds, we can just go, well, it goes 6.7 meters per second east times 11 seconds. 74 meters. Now I see the doubt in some of your eyes. I see some of you going, what the heck? And you don't believe me. And when I was in high school in your spot in grade 11 physics, my teacher said kind of the same thing, and I didn't believe him either. So I like the other method. It's a lot longer and it takes more steps, but for my own sake, I was able to say, oh, okay, so it does move that way. So I'm going to show you that one. It takes a second or two to set up. We know the boat is traveling 7.4 meters per second in that direction, and it does it for 11 seconds. But the reason why that we can't just multiply 7.4 times 11 and say that's the width of the river is because this is the width of the river. And the boat's not traveling on that line. It's traveling, bless you, on this line. So if we go 7.4 meters per second times 11 seconds, that will give us what? 81.4. So round that to 81 meters. So what is 81 meters? The diagonal distance. That's the distance that the boat actually traveled. It's not the width of the river, but it's the distance the boat traveled. Well, can we use that in some way? So we know the distance on that diagonal is 81 meters. Do we know anything else about this triangle? The angle. We know that we got a 90-degree angle there, and we know that this is 24.8 degrees. So just using your basic SOHCAHTOA, you could figure out the other two sides, couldn't you? So I guarantee if you do the process, you're going to find that this side is close to 74 meters. Now we've rounded our answer, so it might be a little bit off, but you'd find that it's going to be close to 74 meters. And then you could also find this side as well using SOHCAHTOA, and that'll tell you how far north you've traveled. Now, if you want to know quickly what it is, we could say, well, it was 3.1 meters per second times 11 seconds, which is 33. 34. So it's going to have traveled from this point here. Let's do a different color. It was trying to get to that point there. It got pushed to this point here. So that distance is how far north it got pushed. And that would be 34 meters. The important thing with this method here is to realize that while it's the same triangle, we actually do need to set up two separate triangles for this. Because this one, our units are meters per second, and this one, our units are just meters. So too often I will see students, they'll try and do a combination of the both. They'll say, okay, well, 7.4 meters per second. Oh, and I know that this is 34 meters. Oh, now I can solve this triangle here. Well, you're dealing with two completely different units. So it's not even the same language, it's not the same triangle there. So make sure that you don't do that. If you do this method, set it up as two separate triangles. So this next bit here is course correction. This is kind of tricky. So if the boat wants to go directly east, in what direction must it travel in? Now we've already talked about this with that little vector addition thing, right? So I think Nicole, what did you say? If the river's pushing it north, what direction does it have to kind of go in? South. Or you said down, you said south. Where? So what can't we change? We can't change the river. So the river vector has to remain the same. So we might as well draw that in there. And it was 3.1 meters per second. We can't change that. All right? What do we want our result to be? What do we want to have happen? We want the boat to go straight across. So the boat's starting, let's say the boat's starting here. Okay? We want it to end up going that way. Exactly east. That's what we want to have happen. How do we get that to happen? We get the boat to point south. All right? In which direction exactly? Well, we got to figure that out. But we want the boat to go off in that direction there. Okay? What is this vector here? The boat. What are we going to put for that? Do we know how fast the boat goes by itself? 6.7. Remember, that's just the boat by itself, before it gets any other forces acting on it, before it gets any other pushes or pulls. So the boat can do 6.7 meters per second all by itself. The river still goes 3.1 meters per second. Which angle do we want? That one. Ah, someone just said 24.8 though. Hold on a second. Look at our original triangle. The boat is one side, the river is the other side, and the result is the hypotenuse. Look at our new triangle. River's one side, the boat is now the hypotenuse, and the result is the other side. Is this the same triangle? No, it's a completely new triangle. So that's why I labeled this theta 2. Because not only is it a new triangle, this is going to be a new angle. So go and solve for those two things there. So again, you can't use tan because you're not given the two sides, so now you have to use sine for this one. All right? So you're given 27.6 is your angle. Do we need to find the side here, the magnitude of this velocity? No. Look. In what direction must it go? It just wants a direction. Which way do I point the boat? That's all it's asking for. So we've got our angle, so what direction do we need to point the boat in? 27.6 degrees. East. 27.6 degrees. South. And you would put that in a little sentence or something, or say we must point the boat east 27.6 degrees south. We put east first because that is our referencing point here. We need to go east and then turn towards the south. What is the new velocity of the boats? 6.7? Oh, because now the river's working against it. So now we need that side. I think you're doing something wrong with your calculator then. So 5.9 meters per second. What is the direction? No, not 27 east, blah, 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 blah. It's east. It's a trick question. Everyone falls for this one. The whole point of doing this is so the boat will go east. So that is the new resultant velocity. It is 5.9 meters per second east. Done.
Can you explain